Hello, my dear students. I hope that you can hear me well. So please, if you can hear me, if you can see the screen well, write something in the chat section. So that I know that everything is okay. Yes, great. Very good. Thank you very much. So, today we have a couple of new topics. We will speak about data analysis and advanced filtering. And today we are going to start with advanced filtering and then go to data analysis section. So these topics are the advanced topics already because they will actually make you stand out from the standard Excel users. So can you hear me right now? Yep, now it's okay. Okay, that's great. So these topics are going to make you stand out of standard Excel users because these topics are rather difficult, but at the same time they give us a lot of possibilities to make our work much more efficient. So let us create a new worksheet. It's going to be lecture 6.1, the sixth lecture already. That's amazing. And so what are we going to have here? We're going to start with the advanced filter. So you remember that we can filter out our different values, and it is not that bad, it is not that difficult, because we can just use this button like sort and filter, and we can add the filter to the header of our table. But we can have an advanced filtering options that will be able to make our filtering much more complex. So let's try to create a new table and filter it out with the standard filter. So what is the table going to look like? We're going to have ID, we're going to have name, then probably sex, then date of birth, and base salary. Something like this. Make it bold, make it beautiful, and so on and so forth. So let's try to find some info for our table. Yeah, I suppose that this is going to work very good. So let's insert the data. Let's make the IDs super fast. Fill series and the base salary. I suppose that the base salary may be set as the random between, I don't know, $50,000 or anything, and 150. So let's, by the way, this is not looking very good. Let's divide it by, or multiply it by 1,000. from 50 to 150. Yeah, this way is going to be much more interesting, and let us also format it in a beautiful way. Okay, so we have a standard table. We have several values. I suppose 15 values is enough for us to get the idea of our table. So what would we like to find out? We would like to filter out all the male employees that were born after the year like 70 maybe, and we want to also filter out women whose date of birth is no less than 85, like year of 85. So how would we do this? Of course, with the standard filter we can do something like this. We can just go to filter, then we're going to select males, and then we're going to go to the date of birth and select everyone like after the 1st of January. Oh, the 1st of January. Oh my god. Okay, let's choose it like this. Why? Okay. '85, or let's say 80. Yep, so that's our filter. But we also want to add women who were born after the 90s. So how to do that? We can go to male, or we can add females, and we can also add the filter. For example, and after 90. Like this. And well, we have some results, but you see that we do not have males that were born before the 90s. And that is the problem. We cannot make this selection, we cannot create this filter using 2 or more conditions. And that is the problem of the standard filter. Let's delete the filter. And now we will create an extended filter. So, how to create the advanced filter? First of all, in the spare space of the worksheet, we need to create a new table with the header, of course. And in the header, we specify the columns that are going to be used in our filter conditions. So if we want to have males and females and date of birth, we will have sex and date of birth columns in the new table, like this. Then we need to specify the conditions of our filter. That is why what we're going to do, we're going to have male, and date of birth is more or equal to the 1st of January 1980. And if we speak about females, female, more or equal to the 1st, let's say 1985. And that's it. and how to apply this filter to our table. To do that, we just put our mouse pointer on any place of our table, go to Data, we have this filter area, and we have Advanced. Click on Advanced, it selects our initial table automatically, and then we can filter the list in place or copy to another location. It's up to us. We will filter the list in place, or let's copy it somewhere here. Yep. Yep, and list range. Oh, I just deleted the list range, so that's not the problem. Let's just select the right range. That's all right. Criteria range is the table, the new table that we created, and copy to somewhere here. Let's do it this way. And then we press OK. Press OK. Let's have like this. Yep, pretty good. And now pay attention that we have males that were born after 1980. You see 85, 88, and females that were born after 85. Like this. So we have a good filter, a good extended filter in our worksheet. Of course, the idea, or to understand the idea that there is a filter, you can see, or you can observe it by the ID numbers that did change. So this is one of the main pointers. Of course, if you filter it out in the main file without copying the data, you will just have all the different rows hidden. So that is it. So let's change the conditions. We want to find all of the people whose name is, let me see, here we have Allison. Let's name somebody Allison as well. Allison, and we have Alice is going to be Allison. So we want to find all the people with the name Allison. What are we going to do? We are going to change our criteria table. How to do that? Well, all that we need to do, let's make a new table here. We just need the name. And then the name is going to be Allison. Like this. Let's try to create a filter. Of course, we can do something like this. We just can set the Allison without the semicolons. Let's go to Advanced Filter, Criteria Range, and copy to another location. Let's choose the location there. Like this. Press OK. Oh, and we have some problems. We cannot find the Allison. Oh, I see what the problem is. I did not change the criteria range. Probably. Let's delete this. Well, advanced list range, criteria range is going to be name Allison. And copy to, yeah, copy here. Press OK. And you see that we have Alison Brock, Alison Meza. And that's it. And let's have another criteria. We want to find all the males with the base salary starting from $100,000 and all the women with the base salary starting from $50,000 to $100,000. How to filter it out? Of course, we are going to have the sex condition, and of course, we are going to have the base salary. So, we want to have all the males whose base salary is more or equal to $100,000 or rubles. And what about females? We want all the females with the salary or base salary more or equal to $50,000 and less or equal to $100. How to do this? If we go with female and less or equal to $100,000, we're going to have a mistake. Let us observe it. Let's go to advanced. Criteria range is going to be with the new table, and we are going to copy it below. It is going to go here. Press OK. Yep. And we have additional interesting features. And what do we have? And we have problems because we have all the males with the salaries more than $100,000, which is absolutely correct. But look at the females. We have female with the salary more than $100,000. Yeah, and we probably have a mistake. And here is the problem, that if you want to set several criteria for one column, you need to do it the following way. Let's delete this. Let's clear that out as well. We do not do it this way, but we need to add a new column, which is called base salary again, and we're going to write the condition right here. So the table, the criteria table, is going to look like this. Female with the base salary more or equal to 50,000 rubles and less or equal to 100,000 rubles. And now, when we go to data, advanced filter, the criteria range is here, and we're going to copy them right here. Press OK. And now look, we have all the males with the salaries more than $100,000 and all the females with the salaries more than $53,000 and less than $100,000. So that's it. That's how we work with the advanced filters. It is not that difficult, but it actually takes time to practice. Okay, do you have any questions about the advanced filters? I see, no questions. Okay, so now we will go to the section of data analysis. Lecture 6.2. And the first thing that we are going to speak about is called the what-if analysis. So, what-if analysis is one of the tools of analysis and optimization that are present in Excel. We will start with the most simple and the basic one, and the basic feature called what-if analysis. Of course, you probably mentioned a new button or a button in the data tab, which is called what-if analysis. And actually, it is just the title for 3 tools, like Scenario Manager, Goal Seek, and Data Table. But in general, all these tools help us to find the values so that we can meet some criteria or some conditions. So let's start with the first tool. We're going to have the Goal Seek, and we will start with a simple, very simple table. We are going to have exams in summer, for example, in summer, and we have several subjects. For example, we have English, we have math, we have probably economics maybe, then have information technologies, then probably philosophy. So we have 5 exams, and let us say that, oh, by the way, let's delete the math. Let's go with these subjects only. Yeah, that would be enough. So, what did we have? We have passed English, economics, and philosophy by now. For English, we got 59 points. Economics, we got 74 points, and philosophy was 79 points. And we did not pass the information technologies exam yet. That is why we need to find the exam or the point that we need to get for this exam so that we are able to apply to I don't know. Let me see what we're going to do with that. Yeah, like scholarship. Yeah, scholarship. So we need to have the GPA more than 85 points. So our GPA right now equals to average, and we got all of the points here. So by now we have 80 points, but we need to have more than 85 points, and we need to find how many points we need to get for information technologies exam. How to do this? So we are going to use the what-if analysis. So we are going to use the what-if analysis, and goal seek. We are going set the cell GPA to value 85 because we need 85 points for GPA. And we are going to change cell information technologies. We press OK, and now we see that goal seeking was actually stopped and it found a solution. The target value was 85, the current value is 85, and we got 98 points to pass for information technologies. So that's it. Goal seek is one of the basic tools that we can use for data analysis. Is it clear? I see. Okay. So now we will use other tools that we can find in the what if analysis section. So first of all, what we can do, we can work with the strategies when we use the tool called Scenario Manager. So let's create a new worksheet 6.3, get a little bit bigger. And let us assume that we are investors. We want to invest our money so that we can get some profit, probably. We have a set of potential projects, and we need to find out which project is the best option to invest. Well, let's create a new vertical table. We're going to have investment amount. We have annual rate, like the rate that we're going to get each year. Then we have the duration in months. And let us assume that we have $500,000 of investment. Annual rate is going to be 15%, and duration in months is going to be 36 months. What can we count based on this data? We are going to count the annual profit, then monthly profit, and of course we're going to have the total profit. How to count the annual profit? So we've got the annual rate and we've got the investment amount. That is why what we're going to do, we're going to multiply investment amount by the annual rate. Then we are going to have the monthly profit. It is very easy to find. We just divide annual profit by 12 because we have 12 months. And the total profit is going to be monthly profit multiplied by the duration. And this is our final profit. So now we are going to create several projects . So of course we are going to have several projects. I suppose maybe 4 of them. And in order to work with these projects, we are going to use the scenarios. So let's go to what if analysis and we choose scenario manager. And you can see that we do not have any scenarios. We can add some scenarios and we will be able to work with them. So first of all, before we start working with the scenarios, I propose you make our data a little bit more clear for us. And we will just create some named cells. So we will select this table. And then we just go to formulas. You see we have name manager and we just select create from selection. And we are going to set this left column as the title to our cells. And now you can see that we have investment amount, annual rate, duration in months, and so on and so forth. So that we've got much more beautiful outputs when we finish working with the scenario manager. And then we go to scenario manager and we start adding the new scenario. So scenario name is going to be the title of our project. Let's say that we want to have a supermarket. Or let's have just a shop. We are going to change the cells investment amount, annual rate, and duration in months, like this. And the comment is going to be, I don't know, any comment, like shop project. That's okay. And now we need to enter values for each of the changing cells. So investment amount is going to be $3 million. $3 million. Annual rate is going to be 10%, and duration in months is going to be 60 months. Press OK. And now you see that we have a new scenario, and we can, by the way, show it and see the results. Let's add 3 more scenarios. I suppose that the fuel or gas station, fuel station is going to be fuel station project, fuel station project, okay. Investment is going to be $1 million. Annual rate is going to be 25%, and no, not 25, 5%, and duration in months is going to be 36 months. Press OK. We can show this data right here. as you can see. Then we go to the new project, which is going to be the e-commerce shop. E-commerce shop project. Of course, the comment is optional, but it helps us to understand what project we do have. So investment is going to be 1 million as well. Annual rate is going to be 25%, and duration in months is going to be 24 months. Press OK, and finally we're going to have the real estate project. Okay, investment is going to be 20 million. Annual rate is going to be 3% only, and duration in months is going to be 120 months. 120 months, of course, it is like 10 years. Press OK, and that's it. So what can we do right now? We have all 4 scenarios ready, and first of all, what we can do with them, we can just show them. So you see the values here do change based on what scenario we choose. But one of the most important and one of the most interesting things that we can create is the report or the summary. Let's choose the summary. We can set the scenario summary. So what result cells actually interest us? I suppose that all the cells interest us. And we're going to have the scenario summary. Press OK. Oh, let's delete this. Delete. Let's return. Go to What If Analysis, Scenario Manager, Summary. The result cells are only the final cells that we are going to have. Press OK. And now you can see these are the titles of the cells that we have. And we have the current values, and we have 4 projects that we got based on our scenarios. And now we are able to choose which profit actually interests us. And we can see that the biggest profit is for the real estate. So that's it. We also can print out the summary as the pivot table, and it is going to look like this. We can just have a filter. Yep, but in general, we have all the values for all the projects that we had. We also can work with them, which makes no sense. And that's it. That's how we work with the What If Analysis Scenario Manager. Please tell me, is this clear? Okay, very good. So some problems with the connection, but everything is stable now. Okay, let's continue working with the data analysis tools. So the final tool that we have in the what-if analysis is called the data table. So what is it? What is a data table and how it works? For example, let us assume that we have a certain amount of money. I'm going to have lecture 7.4. Oh, 7.4, 6.4. So let's assume that we have certain amount of money that we want to put to a bank deposit. And we have several banks that have different conditions, different terms, and so on and so forth. And we want to see what money we are going to get depending on different banks or different terms. So let's create several cells with the terms that actually bother us. So we have the deposit amount, we've got the annual rate, we've got the monthly rate, and we've got the duration of our deposit in months. So the deposit is going to be $1 million. Annual rate is going to be 9%. Monthly rate is going to be annual rate divided by 12. Goes in percent. Let us make it this way. And the duration in months is going to be 36. So we're not going to have the profit here, but let's have the amount in the end. And in order to find the amount that we're going to get in the end, we're going to use the financial function. What financial function are we going to use? We are going to use the financial function which is called FV. We go FV. It is the abbreviation of future value. Okay. Future value, we have rate, number of periods, and we can also look at all of the elements of this function. We have rate, interest rate per period, number of periods, then payment made each period, then present value, and type, like at the end of the period, at the beginning of the period. So what do we have here? Of course, our rate is going to be the rate per period. So we have periods counted in months, that is why we have the monthly rate. Then number of periods is going to be 36. Then we have 0 because we do not have any payments per month, and the deposit amount as the present value. And then the type is 0 because we do not have any payments at the beginning of the period, we have everything in the end. Then press enter, and that's it. So the future value. Do not pay attention that it is represented in, let's have euro, with minus sign. It is not a mistake, it is just how this function works. So what finally do we have? We have profit, and profit is going to be minus 1 multiplied by amount in the end plus deposit amount. And that's it. So we've got $308,000. Then we need to have profit per month, and that's it. We just divided by 12. So this is our profit per month. These are the terms just for one bank only, but we have a lot of banks and we have different terms. How to do this? So let us assume that some of the banks do have the following terms from the annual rate, which equals to 7% up to 10.5%. Oh. Like this. And up to 10.5. And we have different durations, starting from 3 up to 36, with a step of 3. Yep, 36. So let's have small formatting. Oh, not this one. So this is the annual rate, this is the duration. So what would we like to have? We want to have the final, like, profit per month represented in each of the cell on the cross of these terms. How to do this? Of course, we can do something with the fixed values, the array formulas, and so on and so forth, but we can use the what-if analysis, which is going to be much faster and much more efficient. How to do this? Well, we just copy the function of profit per month value and put it right here in the corner of our table. Let's make it as the money. And then we select all the cells that we need to fill in with the values, and we go to data, what if analysis, and data table. So what is the raw input cell? Well, we've got it, raw input cell, and we've got the column input cell. And that's it. But what is the problem? We need to select all the values right here. So don't forget about the main function that is right there. Go to what if analysis, data table, raw input cell, column input cell, press OK. Oh my god, I'm so sorry. Raw input cell is going to be the duration in months, column input cell is going to be annual rate, press OK. And now we've got all the values right here. So you can see that we have 36 months and we have the annual rate at 9%, and we have absolutely the same value. And now we are able to choose which terms are the best for us. So is this clear? Very good. So the next section that we're going to have is the problem of optimization that we will use with the tool which is called the data analysis tool. Or solver. So by the way, what you need to know, so we have these tools right here, but you may not have them. You may not have them because by default they are not placed in Excel. How to turn them on? Just need to go to Excel, then Preferences, if I'm not mistaken, we go to General. Nope, not General. Well, let me see. Actually forgot about it. It's very interesting. Well, actually, I do not remember where it was situated. Let me see, 1 second. Can go to, let me see, Tools. Yep, Excel add-ins. Yep, and we have Analysis Tool Pack, Save as Adobe PDF, and Solver. So what we need to have the Analysis Tool Pack and the Solver add-in. Press OK, and then they are going to be placed here. So it depends on the operation systems that you've got, because on Windows we have one option to turn them on, and on macOS we have another option, and another way how to turn it on, as you can see. So what task we may have with the solver. This tool is pretty complex. I suppose that sometimes you're not going to use it at all, but you need to know how it works, because this way you will be able to solve the tasks that you were not able to solve before. So we'll start with the economic task. Let's assume that we have a new table. We've got 3 products: product A, product B, and product C. And we've got production costs, production cost, and price. The price that we sell these products. Product C, production cost, price. So we are going to have the cost as 400, 3,200, and 2,500. And the price is going to be 500, 4,000, and 3,000. Then produced revenue and costs. So let's assume that we produce 30 pieces of product A, then 40 pieces of product B, and 30 pieces of product C. The revenue is going to be 30 multiplied by the price. We've got to do this with the formula, and the costs are going to be the produced pieces multiplied by the production cost, and that's it. Like this. So what our profit is going to be. In order to find the profit, let's create a new column which is called total, and we're going to have the sums of the values. We have total produced, we have total revenue, and we have total costs. And in order to find the profit, we are going to subtract costs from revenue. And the profit is 50,000 rubles, or dollars. So this is just general stories that we have. But we may have some restrictions. For example, we may assume that we are not supposed to produce more than some quantity. For example, first of all, we need to produce at least and produce no more than. So produce at least 10, 15, and 15 goods, no more than 100, then 60 and 30. And total pieces produced no more than 100. Like this. And maximum costs should be $150,000. So we need to find the number of pieces that we need to produce in order to satisfy these restrictions. We are going to use the solver tool, which is situated right there. You can see that we have different solver parameters. And what are we going to do? First of all, we need to pay attention that our objective is to maximize our profit. We go to profit and we need to set it to max. And we are going to change the cells of produced. And then we need to specify the constraints. What constraints do we have? So let's add some. First of all, we see that produced should be no more than, well, more or equal to produce at least. Produce at least. Add. Then produced should be no more than produce no more. Produce no more. Add. Then total pieces should be no more than total pieces produced. Add. And finally, we have the max costs. These are they should be no more than max costs. Add. And finally, what we have several options there, like more or equal, less or equal, equal, integer, binary, and different. So what does it mean? Integer means that all the values should be integers. Binary means that we have or are going to have only binary values, and different, that all the values are going to be different. So in our case, we need to specify that the produced numbers are going to be integers. And that's it. So what are we going to have? We have the restrictions here. And finally, we can find the solution. We are going to select the simplex method, so it's usually used for solving these tasks. Go to options, and we need to pay attention that we are not going to ignore integer constraints, because by default it may be set. Press OK. Then we try to solve it. And we have our solution. We have 57, 28, and 15 for production. You can see that the total cost is less than the maximum costs. The total pieces produced are 100 pieces, and the profit is the maximum profit possible with the scenarios provided. And one more task for which we can use our solver. Let's assume that we have a table. We have several players in the team. Player. And we have skill level. Make it bold, make it beautiful. And we have player 1 up to player 10. And skill level is going to be random between 1 and 10. like this. So what would we like to do? Our task is to divide our players into two teams so that the skill level of both teams, the skill levels of both teams are as close as possible to each other, so that the difference between them is as minimum as possible. How can we do this? So we will, of course, use the solver tool. And in order to do this, we are going to add some columns to our table. So first of all, we're going to have team A. Make it bold and beautiful. And team B. So in order to find the team A players, so we can actually assign them in a random order. So we will use 1, 1, 1, 1, 1, 0, 0, 0, 0, 0. So we will use binary values like ones and zeros. In order to find the players in team B, we are going to use the formula. So how are we going to use this? Well, we can use the formula, which is the ABS this minus 1. So ABS is an absolute number. And anytime we've got the changes here, we're going to have the changes in team B. Then we need to make sure that there are only 5 team members in a team. For that, we're going to use the sum. And you see we have 5 team members in each team. And then let's count the skill level of team A and team B. Team A skill, team B skill. We just multiply skill level by the numbers. And team B skill is skill level multiplied by, well, skill level multiplied by team B. And we will have the sums of skill levels as well. And you see that we have a great difference, 24 and 13. So the difference, make it bold and beautiful, equals to 24 minus 13, and of course we are going to have absolute value. So we have 11. And this is the problem. This is the problem. So, first of all, let's make the formatting of our table so that we are able to see all the values in a clear way and all the results much more clear. So we are going to do the following. We're going to conditional formatting, and we're going to use the new rule. Go to classic, and we're going to use the formula. If team A more than or equal 1, press. And if it is team 1, we're going to have yellow. Press OK. Let's have not fixed cell, but cell C2. Press OK. And the same with conditional formatting, new rule, classic, formula. It is D2 equal 1. It's going to be green. Like this. So you see that all these team members in the team A are going to be yellow and team B are going to be green. So let's go to the solver tool solver. We have the solver parameters, and our objective is to make the difference as minimal as possible by changing variable cells of team A, because these are the only cells that we change. And now we are going to have the following constraints. Okay, first of all, we need to specify that the sum of team A equals to 5. Then the sum of team B equals to 5 as well. And the values of team A are going to be binary. Only zeros or ones, like this. So now we have our restrictions done. And what is the solution method that we're going to have? Well, usually the simplex method is used to solve the tasks. But if the simplex method gives us a mistake, that means that it is not applicable to this problem. Actually, for this problem, simplex method is not going to be used. We are going to use, well, evolutionary method of solution, so that our computer will be able to look through all the options and find the one that fits best. Of course, we can go to options, we can go to evolutionary and check up that we need to require bounds and variables, because, well, if we do not have these bounds, we may not have the results. Press OK. And then we press solve. Now you will be able to see that the changes are made to the initial values and differences count for every possible option. So let us wait a little bit. So you see that we have 730 sub-problems solved, even more. Okay, so we are done actually, and the minimum difference that we may have equals to 1. And this is how we are going to separate the team members in our team. Okay, do you have any questions about the solver tool? Okay, no questions. So, the final tool for today is going to be connected with the data analysis. So it was lecture 6.6, and now we're going to have lecture 6.7. So, data analysis is one of the other possibilities for data analysis, of course. It is turned on the same way as the solver does. And what is the data analysis? If we click on data analysis, you can observe that this is a collection of like a dozen of tools that we can use for data analysis. Most of them are highly professional, highly connected with maths. That is why we don't need to know all of them. But there are some of them that we may use in order to work with the data on a simple level. So let's start with the tool which is called correlation. So you see correlation here. And we'll have a simple example. We have a simple table which is called months, then number of clients, average temperature, and profit. So what we are going to do, we are going to have several values starting from January to the December. Let's have certain number of clients like 11, 5, 16, 7, 14, 7, 16, 20, 16, 17, 20, and 19. And the average temperature in this month is going to be like minus 15, minus 12, minus 8, 5, 15, 20, 25, then 25, 15, 10, 7, and minus 5. And the profit is going to be, well, let us say random between, but we will have random between 200 or 2000 and 4000 multiplied by the number of clients, like this. Values only. And that's it. What would we like to find out? We would like to find out how much our profit depends on the average temperature. Maybe there is a correlation between the number of clients and the average temperature and the profit. So how to find it? We are going to use the data analysis tool, which is called correlation. Let's go to it. And we have the input range. So what is the input range? We have all of the three columns here. They are grouped by columns and there are labels in first row. And we are going to put everything to a new worksheet. Press OK. And now we are going to have a small table, which is the correlation matrix. And you can see that of course we have ones because profit fully depends on profit. And then how number of clients depend on the average temperature. Well, there is a small correlation. It does not depend. And number of clients depends, well, profit depends on number of clients. Well, absolutely. So average temperature does not depend on clients and profit depends on the number of clients, almost absolutely. And the average temperature is, well, has a bad correlation with the profit. So profit does not depend on the average temperature. So this is it, the most basic data analysis tool that we can use. And one more example that we can do, lecture 6.8, is the following. We can find the Gladden average. Let's insert some values like months and profit. And we have several months like few months. Let us say for 3 months, or for 4 years at least. And we have random random between. let us say 150,000 rubles and 1.5 million. Values only. And if we try to create a chart of this function, we are going to have a very spiky chart. So you can see that the values are pretty unstable. That's obvious because we have, well, we have random function applied, but we can make it a little bit steep with the next data analysis tool. Well, not analyze data. We go to data, data analysis, and we have moving average. So what can we do? We will have the input range with the profit, labels in first row, and the interval is going to be the output range is going to be the very next column, like this. Press OK, and now we've got the moving average. And let's add this column. Let's copy it and paste it to our values. Change chart type is going to be line. And you see that all the peaks and all the high values are now moved to moving average. So we do not have such high peaks as we had before. And final tool that I want to show you, let's call lecture 6.9. It will help us to see the range and percentile. So let's have a new table, which is like exam results. We have student, we have points. Let's have student 1, student 2 up to 50, and we have different points, random between like, I don't know, 20 and 100. Values only. So what we can do, we may see that in the points section we may add the color scales from the least to the highest. Let's make it like this. These are the worst point and the highest is the best point, and we can use the data analysis tool which is called rank and percentile. Press OK. The input range is going to be the points, labels in first row, and everything in the new worksheet. And what are we going to have now? So we have values like point, points, rank, and percent. So the point is the row in which the value was situated. For example, point 16 means that at row number 16 in the table we've got the value, the initial value. Then points is the amount of points each student got. Rank is the place the student got in this kind of competition in the exam. And the percentile is the number of or percent of students that had the marks lower than this student. So this is it. That's the idea of the rank and percentile and other data analysis tools. So please tell me, do you have any questions? No questions. Okay, so that's it for today's lecture. Thank you very much for the lecture and see you in 10 minutes on the practical class. So see you. Bye bye.